The ability to achieve proper takeoff thrust with the JT8D engine is directly related to the application of correct engine trim techniques. This presentation will show the trim procedures applicable to all JT8D engines installed on Boeing 727 aircraft. Trimming procedures for other JT8D powered aircraft are similar and can be found in the applicable aircraft maintenance manuals. Engine trim is required on all newly installed engines or following a fuel control change. Periodic trim adjustments may also be necessary during the life of the engine to correct throttle misalignment and to restore the normal cushion between the takeoff and full throttle positions. Trimming is performed at a part power setting, which provides the following advantages: uses less fuel, reduces exposure time of hot section parts to high temperatures, reduces ground operating noise levels. Engine trim is affected by wind direction and velocity. Thus, to achieve consistently good trim results, the aircraft should be headed into the wind and trimmed when wind velocity or gusts do not exceed certain conditions. Trimming is not recommended when wind conditions exceed 25 miles per hour or when icing conditions prevail. To perform the JT8D trim procedures, the following equipment is recommended: a pressure gauge with adapter hose and fittings for connection to the PT7 test fitting, a precision tachometer with percentage indicator, a thermometer for measuring ambient temperature at the aircraft, calibrated from -20 degrees to +120 degrees Fahrenheit, interphone service equipment, a portable trim kit, a ground service low-pressure air source with 45 psi maximum pressure, or the aircraft APU, a ground service electrical power cart with 90 kVA output, or the aircraft APU. Before starting, refer to the applicable aircraft maintenance manual trim procedure for warnings and cautions regarding personnel and equipment safety. Having removed the engine cowl panels, we see the part power trim stop located here on the fuel control. Its safety wire has been removed. The position of this stop provides the part power setting mentioned earlier. In the activated position, the stop physically limits the power lever travel to less than maximum. The stop is marked with an S for standard on one side and C for cold on the opposite side. The proper position of the stop for trimming is determined from the trim table footnotes. On a hot day, installing the stop with the S side facing out ensures that the anti-surge bleed valves are closed when the power lever is against the part power stop. By removing the stop, turning it over and reinstalling it with the C facing out, the engine can be trimmed on a cold day without exceeding permissible thrust limits. There are two trim adjustments on the fuel control. They are called military and idle. The military adjustment is used to set PT7. Counterclockwise adjustment increases PT7 and clockwise decreases it. This adjustment is made with the power lever against the part power stop. The idle adjustment is used to set N2 idle speed. Counterclockwise rotation of the adjusting screw increases N2 idle speed, and clockwise decreases it. This adjustment is made with the power lever in the idle position. Now, to prepare for trimming, connect the pressure gauge adapter hose to the PT7 test fitting on the engine. mount the remote trim adapter to the fuel control trimmers. Run the other end of the cable and the PT7 hose up to the flight deck. Connect the trim cable to the remote trim box. Connect the PT7 hose to the pressure gauge. Then connect the plug of the precision tachometer adapter cable. The other end connects to the test receptacle in the back of the engineer's panel. The trim tables from the Boeing Aircraft Maintenance Manual contain values for the following parameters: barometric pressure, ambient temperature, idle N2, the percent N2 speed to which the idle trim screw is adjusted. The upper values apply to the number 1 and 3 engines, while the lower values, in parentheses, are for the number 2 engine. The number 3 engine is the one that will be trimmed in this presentation. Part Power PT7. PT7 target to which the military trim screw will be adjusted during part power trim operation. Part Power EPR. Engine pressure ratio reference for flight deck personnel. This value gives an indication of the accuracy of the EPR indicating system. Takeoff EPR. This is the EPR target at which the engine is operated after trim completion to check for availability of takeoff power and the amount of power lever cushion. The ratio of PT7 to ambient pressure is not used as part of the normal trim procedures, but may be used for troubleshooting the number 2 engine EPR indicating system. The trim tables are based on no load, no air bleed, and ground static conditions. Also, the trim table footnotes are used to determine the part power stop position. In order to locate the proper trim table, we must first determine the ambient temperature and the uncorrected local barometric pressure. The uncorrected local barometric pressure value may be obtained from the control tower. The ambient temperature should be taken in the shade of the aircraft. For this example, we will use 72 degrees Fahrenheit for the ambient air temperature and 29.6 inches of mercury for the uncorrected barometric pressure. Using these values, find the appropriate trim table page number in the Maintenance Manual Trim Table Index. This is accomplished by intersecting the barometric pressure of 29.6 with the ambient temperature of 72 degrees Fahrenheit. Once the correct trim table has been located, a trim data worksheet will be needed to record the engine parameters. The worksheet can be patterned after the one in the manual. Due to possible weather changes, the target values should be selected from the table and recorded on the worksheet within 30 minutes of performing the trim. The trim table shows the idle N2% RPM for numbers 1 and 3 engines is 57.8%. Part Power PT7 is 52.7 inches of mercury. Part power EPR is 1.78. And takeoff EPR is 2.04. The tolerances listed on the worksheet are applied to the target values prior to starting the trim procedure. These tolerances are taken from the aircraft maintenance manual. Idle N2% RPM is 57.8, plus 0%, minus 1%, which becomes 57.8 maximum and 56.8 minimum. Part power PT7 is 52.7, plus 0.5 minus 0, which is 53.2 maximum and 52.7 minimum. Part power EPR is 1.78 plus or minus 0.02, which is 1.80 maximum and 1.76 minimum. Before starting the actual trim, the following systems must be turned off: the fuel heater, alternator, air conditioning pack, the low-pressure air bleeds, and engine anti-icing. Next, place the part power trim stop in its proper position and safety wire it. After all necessary precautions for the safety of personnel and equipment have been observed, start the engine and stabilize it at idle for 5 minutes. After the 5-minute warm-up at idle, accelerate the engine from idle to the part power stop 5 times, and then stabilize again at idle. This procedure maximizes fuel control repeatability. Observe N2 speed on the tachometer and record it. With the remote trim box, adjust the idle trim screw to the target value and record it. This setting provides good engine acceleration and satisfactory electrical load carrying capabilities. Slowly advance the power lever until a sudden increase in the EPR is noted. The EPR increase of about 0.05 units indicates that the engine anti-surge bleeds have closed. Advance the power lever to the part power stop. On some aircraft models, it is necessary to position the oil cooler switch to ground off. Caution! The period of operation with the oil cooler switch in the ground off position should be as short as possible to avoid overheating the constant speed drive. This can be monitored by observing the generator drive oil temperature indicator during trim runs. Next, observe the PT7 value and record it. Also record the part power EPR. If PT7 is not the target value, activate the remote trim box and adjust the military trim screw until the target is reached. Record PT7 and EPR. Turn the oil cooler switch to normal. Then slowly retard the power lever to idle. And note the EPR decrease of approximately 0.05 units, which indicates that the engine anti-surge bleeds have opened. Because the idle and part power adjustments affect each other, more than one trim adjustment may be required. If an adjustment at either the idle or the part power setting has been performed, the other setting should be checked. The final idle and part power turn adjustments must be made in the increased direction to assure repeatability. When both the idle and part power trim targets have been met, return the power lever to idle. Next, remove the safety wire from the part power stop, and then safety wire it in the stowed position with the S facing out. Now advance the power lever and set takeoff EPR, which in this case is 2.04 EPR, and stabilize for at least 30 seconds. Record EPR, N1, N2, EGT, and fuel flow. It should be possible to obtain takeoff EPR at less than full power lever travel, and engine operating parameters should be within redline limits. With a marking pencil or a piece of tape, mark the position of the forward edge of the power lever on the control stand. Prior to engine shutdown, perform an accel-decel check. Then slowly retard the power lever to idle. Stabilize the engine 5 minutes for cooling and perform a normal engine shutdown. Next, advance the power lever to the full thrust position and allow it to spring back. Measure and record the distance between the leading edge of the power lever in this spring-back position and the takeoff mark on the control stand. Depending on ambient temperature and pressure conditions and rigging tolerances, the unused travel on the stand should be between 1.0 and 1.75 inches. This is called the throttle cushion. After recording the throttle cushion, return the power lever to the idle position. Remove the trim equipment and replace the cowl panels. This concludes the description of trim procedures for the Pratt & Whitney JT8D engine as installed on Boeing 727 aircraft.